Well, welcome. This is a supplemental screencast to our Math 141 at SUNY Geneseo lesson on functions. Just want to show a couple of examples of functions and how we might represent them in multiple ways. Because if we can represent functions in multiple ways, we can show kids different ways to think about how the machine works. So consider this table if you would. Uh, First, let's make sure that it is a function, that every input goes to exactly one output, and that appears to be the case here. Every input does have a unique output. So the domain is the set 2, 5, 7, and 10. The codomain and also the range. Well, the range is certainly 7, 16, 22, and 31. The codomain, you can determine it's some set of numbers that at least contains 7, 16, 22, and 31. There are lots of other ways to express this function. We could express this function with an arrow diagram. 2, 5, 7, and 10 over here, 7, 16, 22, and 31 over there, and we see that the inputs map to the outputs. We could do that. We could graph the points. Maybe I want to show more of the first quadrant. 2, 7, 5, 16, 7, 22, 10, 31. Looks like all of those are on a line. And if it looks like all of those are on a line, maybe they are. So we start wondering what the rule is. If they're all on a line, then there's a multiply and an add. So can you think about what we might multiply and add to get from the inputs to the outputs? Can you think of what the rule might be? I'll tell you in about 5 seconds. Okay, so maybe you paused the video and maybe you didn't, but it appears that if we triple and add 1, triple and add 1, triple and add 1, triple and add 1, it looks like our function, the machine, triples and adds 1. Similarly, consider this function. I'll give you 4 inputs and 4 outputs. 1, 4, 9, and 10 on the inputs, 0, 15, 80, and 99 on the outputs. They map, they map, they map, they map. Take some time, play. Try to represent that function in other ways and think about what a rule might be that maps the inputs to the outputs. Hit the pause button, play a little bit. Answers will come in a few seconds if you don't do that. Well, indeed, this does not look like it's on a line. There's a very steep slope here and a steeper slope here. So this is definitely not a line, so it's not multiply and add or subtract. But it happens that if we square the inputs, 1 squared is 1, 4 squared is 16, 9 squared is 81, 10 squared is 100. So we just subtract 1 from the square to get from the inputs to the outputs. And yes, this is a function because there is no input that maps to more than one output. We would see that in a graph by drawing vertical lines through all the dots. If you draw a vertical line through all the dots and it never hits another dot, then you're okay. It's not a, then it is a function. And there we have several different ways to display functions. It is important for you as the teacher to be able to move smoothly back and forth from all of the representations, and it'll help your students to see the interconnectedness of the math.